Hi, I'm Graham Balachi from Building Blocks for Modern Humans. Thank you for joining me. In today's first episode, before we talk about the physical matter that produced the building blocks for modern human society, I'd like to talk about the building blocks of physical matter itself. This way, we'll have a really good understanding of the different types of matter and how those are put together to support modern humans. So, for those of you who remember high school chemistry, this will be something of a review. But let's get into it. This will set the scene for what's to come, and I'm really excited about it. Let's get started. Just a reminder, if you like this content, to please like this video and subscribe to this channel. It really helps out. Thank you so much. So, the matter in the universe and the matter here on planet Earth is the stuff that's all around us. It's all the physical things, the solids, the liquids, the gases, the air, the water, the wood of this table, our physical bodies is all physical matter. And it's really the same tiny particles arranged in different ways to produce all the different types of matter around us. And this is what humans need in different forms to support our modern lifestyles. So these tiny particles, there's a bunch of different types, and they're arranged in different ways. Physicists will have you believe that there's 61 different elementary particles. And you know what? If we're getting into detail, they're probably right. I started off as a physicist, I believe them. I think though, for a good understanding of what humans need for modern societies, you really only have to know about 3 elementary particles and how those are put together to form the elements. And I'll get into that in a second. These 3 fundamental particles are the proton, the neutron, and the electron. These are what combine together to form what are called atoms. And these atoms and the different types of atoms are the elements of physical matter. That's really all there is to it. Now, these atoms are crazy small. To give a perspective on this, imagine you had 11 liters, which is, I don't know, about this much hydrogen gas, which is just a type of gas, which is one of the elements we can talk about later. It's a gas like many others. It's actually a very light gas. Anyways, say you had 11 liters of it. The amount of hydrogen atoms that would be in that volume would be a 6 followed by 23 zeros would be the number of atoms in that volume. That is how tiny these atoms are. And it's really groups of atoms combining together in different ways, which is what produce the plethora of different types of matter around us. So let's take a look at a model of the atom itself. You'll see that there's circles here representing the protons, the neutrons, and the electrons. What you might notice here is that right at the middle of the atom, which is called the nucleus of the atom, you see the protons and the neutrons. The protons and the neutrons are, relative to the electron, very heavy. The proton and the neutrons and the nucleus itself have almost all of the mass of the atom. So when you hold something that's heavy, that's almost entirely what you're feeling is the mass of the protons and the neutrons. The electrons are scattered around the outside of the nucleus of the atom, and they have very little mass. What they do is facilitate the bonding of different atoms together. That's chemistry. That's the exchange of electrons that pull atoms together or apart. That doesn't matter right now, but that's the difference between these things, is the protons and neutrons are at the center and they're almost all the mass. The electrons are flying around the outside and they facilitate the bonding of different atoms together. Okay, so there's a lot of different ways that we can arrange, or rather nature arranges, protons, neutrons, and electrons to produce different types of atoms. There's one major classification scheme that determines what one element is versus another. And it really just boils down to this: how many protons are in that nucleus? That determines what element it is. It can have different amounts of neutrons in that nucleus, but it's the amount of protons that determine what type of element it is. It can have different amounts of electrons around the outside, but what really matters is how many protons are in that nucleus. That is what makes one element different from another. So now let's take a look at all the different elements that humans know about today. And remember, it starts with 1 proton, and then 2 protons, and then 3 protons, and so forth. These are organized into something many people have heard about, but to bring it up again, is the periodic table. which was first developed by a Russian chemist named Dmitry Mendeleev back in 1869. What he noticed is when he took the different types of, we didn't actually have a good idea of what these things were at the time, but he started saying, okay, I have these different elements, and he started putting them in order of the chemical properties that he was seeing. And what he didn't realize, and eventually people came to realize, is what he was doing is putting them in the order of how many protons were in the nucleus. And he noticed a repeating pattern of the chemical properties when he did that. And these were called periods. These repeating patterns were called periods, hence the periodic table. A better name for the number of protons in the nucleus is the atomic number. Here's an example of carbon. You'll see that there's a chemical symbol, which is C for carbon, and above it is the atomic number 6. And that's because there's 6 protons in the nucleus. Real simple. Below it is the atomic mass, and that is the combination of protons and neutrons together. It's a little over 12 because sometimes there's more than 6 neutrons. Very rarely though, so usually it's in and around 12. So let's take a look at the periodic table now. Starting in the top left, that is number 1. That's where we have the atomic number 1, which means we have 1 proton in that nucleus. That is hydrogen, which is the gas I talked about earlier in this video. That is the lightest element possible because it has only 1 proton. Then we move on to helium, number 2. That has 2 protons in the nucleus. As you can see here, we have the 2 blue balls in the nucleus representing the 2 protons and the 2 red balls representing the 2 neutrons. The next one is lithium, number 3. That has 3 protons in the nucleus, and so forth. And we can take a look at a bunch of different examples of these elements that all have the basic property of how many protons are in that nucleus. For fun, let's take a look at a couple of the big boys. So coming in at atomic number 79 is one that's very popular in the world, is gold. Look at the size of this atom. Coming in at number 92 is uranium, which I'm a big fan of for its role in nuclear energy. From there, we can start to understand how all these elements are combined together to produce the physical building blocks for modern human society. So that's what I wanted to do today, was introduce the building blocks of matter itself, so we can understand later when I talk about something like, hey, this is how much nitrogen the human race needs to sustain itself right now. This is how much iron the human race needs right now to sustain itself. We can take a look at the periodic table and say, oh yeah, that's what type of element that is. And then also sometimes these elements combine together in different ways to produce different compounds, which are combinations of these elements. And we can start to think about, where do we get all those pieces and how do we combine them together to produce what humans need? So this really is the basis. I hope you guys got something out of this video. Please like and subscribe and comment below. I look forward to hearing from you. Stay tuned for next time. We're going to get into some actual examples of these building blocks. Thank you so much.